In the previous video about systems of equations, we talked about the different types of answers you could get. These two equations right here could be parallel. That means they would never intersect. There would be no solution. They could intersect at a point, and that one point would be the solution for this system of equations. Or these two systems could be the exact same line, and it have infinite number of solutions. What we need to do here is this. They're going to give you two lines, and they want to know whether or not this point is on both of these lines, whether or not this point is where these two lines intersect. So what we're going to do is we're going to use these numbers right here, plug them into the appropriate spots, and see if it works for both equations. Now remember, a point consists of an x-coordinate and a y-coordinate. That's going to tell you where the numbers go in each one of these equations. So what we're going to do is we're going to try this top one right here first. X plus y equals 13. X plus y equals 13. We're going to plug these numbers, substitute these numbers into this equation and see if it works. For the x, I need to put a 5. For the y, I need to put 8. And if it's equal to 13, then I know this point is on this line. 5 plus 8 is 13. So I know that this point right here is on this first line. Now I need to check and see if it's on this second line. So I'm going to use this second equation. I'm going to substitute the numbers in at the appropriate spots and see if it works for this one. So I want to put a 5 for the x. Minus 8 is equal to 3. 5 minus 8, negative 3, is not equal to 3. So this point right here is not a solution. It's not a point for both of these lines. This point right here has to work for both equations for this point to be a solution. So is the point 5, 8 a solution to this system? No, because as soon as you get one that doesn't work, it's got to be a solution for both of them. Let's determine if this ordered pair is a solution to these two lines. See if it's a solution for this system of equation. So what I'm going to do again is I'm going to substitute the numbers in the appropriate spots. This is going to be my x this time, and this is going to be my y. This is the top equation. I'm going to substitute, plug in the numbers in the appropriate spot. For everywhere I see an x, I need to put an 8 plus 5 is equal to 13. 8 plus 5 is equal to 13. So it is checking out for this first equation. Let's see if it works for the second equation. Second equation is x minus y is equal to 3. This time my x is 8. My y is 5. 8 minus 5 is 3. This ordered pair is working for both of these equations. That means, yes, it is a solution. This ordered pair is a solution to this systems of equations. This is the point that these two lines intersect. So let's try another example. I need to see or determine if this ordered pair is a solution to this systems of equation. So what I'm going to do is I'm going to start with the top equation up there. 2x minus 6y is equal to 20. And I'm going to substitute these two numbers in the appropriate spot. This is my x-coordinate and this is my y-coordinate. 2 parentheses minus 6 parentheses equals 20. I'm going to use parentheses where each one of the variables is located. That way I've got a spot to put those numbers in there, and it also tells me what I need to do with this number in front of each one of these variables. This number in front of this variable needs to be multiplied. So I'm going to put negative 16 in for x, and I'm going to put 10 in for y. 2 times negative 16 Negative 6 times 10. Negative 32 minus 60. Immediately I can tell that these two numbers aren't equal, and therefore this ordered pair does not work. As soon as I find it not working for one of them, it doesn't matter if it doesn't work for or works for the next one. So no, this ordered pair is not a solution to this system right here. Let's see if this ordered pair is a solution for this system of equations. Again, I need to take the appropriate numbers and substitute them in for the appropriate letters. And what I'm going to do is I'm going to use this first equation, and everywhere I see a variable, I'm going to put a pair of parentheses. That's going to help me insert the numbers and realize I need to multiply. This is my x coordinate, this is my y coordinate. Everywhere I see an x, I need to put a 4. Everywhere I see a y, I put a negative 2. Now I need to follow my order of operations over here, and it should be equal to 20. 2 times 4 is 8. Negative 6 times negative 2 is positive 12. 8 plus 12 is 20. 20 is equal to 20. So it's working for this first equation. Now it needs to work for the second equation also. I'm going to rewrite this equation right here, and everywhere I see a variable, I want to put parentheses. That's going to help me inserting the numbers, and it's going to help me realize that I need to multiply. Everywhere there's an x, I should put 4. Everywhere there's a y, I should put negative 2. 3 times 4 is 12. 5 times negative 2, negative 10. That should be equal to 2. 12 minus 10, 2 is equal to 2. That one's checking out as well. Is this ordered pair a solution to this systems of equations? Yes. Is this ordered pair a solution to this systems of equation? It doesn't matter what order it's written in. Again, you need to start plugging in the numbers and see if it works for both of them. Remember, it has to work for both of them. So this is my x and this is my y. For this one right here, my y is 9 is equal to my x is 1 plus 6. 9 is equal to 7. No, it's not. So I immediately can say, no, that is not a solution to this systems of equations. Next example, I need to see if this is a solution to this systems of equation. So I'm going to start plugging things in. This is my x and this is my y. For this first one right here, my y is 8 is equal to 1 plus 7. 8 is equal to 8. So it's working for this first one. Let's see if it works for the second one. Right here, I need to plug in what it says for x. It says a 1 goes right there. Is 1 equal to 2? No. No. This is not a solution to this system of equations.